Welcome to the lesson number 2 in the chapter 8, that is graphs of polar functions. I hope you have watched the videos of lesson 1. If you have not watched it, please go and watch the previous videos. Be thorough with the lesson 1 and then continue to lesson 2 because they are in continuity. You need the information and knowledge of lesson 1 to understand lesson 2 thoroughly. The learning objectives of this lesson are graphing polar equations. It is very simple and straightforward. By table of values, you plot the points and graph. And the second objective is to identify and graph classical curves. Classical curves are like a special type of curves which we'll come across in this lesson. And the keywords which you'll come across this lesson are cardioid, limaçon, the C with the this line over here, the dash is called limaçon, lemniscate, rose, spiral of Archimedes. This is pronounced as Archimedes. Now these are the keywords. These you may not have heard this before because these are the classical curves. These are the special type of curves which we'll study in the second objective. Before we continue with the lesson, I will just introduce a little bit on this special type of curves, the keywords, and then from the next video we will solve example problems of this lesson. Here, sorry. Now these are the special type of graphs, polar graphs. Polar is relating to circle, angled circle. So now first is circles, basic circles. But look over here, when you have equation like this, r equals a cos theta or r equals a sine theta, if you graph this, then you will come across a circle graph. Now, what is the difference over here? There are four types of graphs, four types of circles, sorry. One is at the right side, one is at the left, up and down. It's very simple. If it's cos, it will always be the right or left. If it's sine, it's up or down because sine is related to the vertical and cos to the horizontal, x. Okay, over here it's related to the x-axis, sine is with the y-axis. Now, how does it change right and left? Whenever it's greater, this radius, the a value, not the radius, the a value, the constant is greater than 0. That means it's 1, 2, 3, any positive values, then it will be at the right. If it's less, it's in the left. Similarly, whenever greater in the vertical axis is up and less than will be down. So this is the thing. And you know the graph, the polar grid from the last lesson. It's from 0, 90 degree is pi by 2, 180 is pi, 3 pi by 2 is 270 degree, and then you continue again, 360, it's continuation. Now, limaçons are something like this. You can see sometimes there'll be a curve over here, there'll be a small inner circle, sometimes it'll be just like a heart shape. Now, here's the standard formula. Whenever you have r equals a plus or minus b cos theta, or it's sine theta over here. So then you will get such graphs. Now, again, you must, just now we saw in the circles, whenever we have cos, what happens? It's either right or left. When it's sine, it's up or down. So this is the thing. Now you can see the standard form. You can go across this. We will come across this again. But now, before going to the limaçon, I want to say there is cardioids also in limaçons. Now, what is this cardioid? Cardioid is something like this. See, this is the shape. It's similar, but when we solve problems, you'll come to know the difference when you graph and everything. Over here, the thing about cardioid is the values of A and B are equal. That is the only difference. A limaçon, the same standard form, but only difference is the A and the B, the constant values is equal. If it was R equals 2 plus 2 cos theta, then it's called a cardioid. Only when these two are equal. But if it's less than B or greater than B, or in different cases, you will always get a limaçon itself, but it'll be the dimpled, convex, or inner loop. Then we have roses. Rose, it's like a petal over here. And this is the standard form. It's a cos n theta or a sine n theta. Now over here you can see based on the n values, here the number of petals varies. So you can see whenever it's odd numbers, okay, when it's odd numbers 3, 5, 7, it's just those number of petals. See, this 1, 2, 3, 1, 2, 3, 4, 5. When the rows has n, if n is odd and n is even, there's two different cases, okay? When it's odd, it's just those same. But when it's even, look over here, instead of 4, we have 2 times it, that's 8. 1, 2, 3, 4, 5, 6, 7, 8. If it's 2, we have 4. So this is the relation over here. And then lemniscate and spiral of Archimedes. Lemniscates are like this with the standard form of a square cos 2 theta, or sorry, r square equals, or r square equals a square sine 2 theta. And the graph is similar to this. And last one, spiral of Archimedes, it's a spiral. Now the standard form is very simple, r equals a theta plus b. Now the pronunciation is given as Archimedes, and now this is how it looks. Don't worry about this. If you cannot understand at once, no worries, because we will solve problems. You'll be more thorough. This is just introduction to all these graphs. It's better to understand the shape now and the standard form. When they ask you the question spiral of Archimedes, or they give you the standard form r equals a theta plus b, you must know that is spiral of Archimedes, or if it's lemniscate or cardioid or circle. So this is an important thing. In the next video, we will start solving the example problems. The example one, we have to graph polar equations by plotting points. Now this is a polar equation. Whenever r equal to the angle is there, it's equation. Equation means equal to sign will exist. Now r equals sine theta. If you remember in the introduction, we had seen this standard form is for a circle. Now, how do we plot? Is by making the table of values. So the step one, make the table of values. So we know it's a polar equation. It'll repeat itself, isn't it? So now it's like a circle. So 0, 90, 180, 270, and then back to 360 degree. So we need to have an entire circle. I mean, like this, So you need to plot points. I mean, take values for theta from 0 to 360. That is why within the interval 0 to 2 pi. This means it is from 0 to 360 degrees. This is what it means. So now make a table where theta is to be assumed and then put it in this equation and find the r value. So we have taken over here in radians, but it's up to you. You can make the table even in degrees. It's fine. So now over here, if you want to convert into radian or degree, it's up to you. But now if you're just changing to radian to degree, it's very simple. We have done it in the last lesson. Instead of pi, may put 180 and then write it as it is. Now, pi by 6 is 30 degrees. And similarly, you can check the other ones. Pi by 3 will be 60. Then this is 90, 120, 150, 180. You can try doing the calculator, or if you know these radian values, if you start solving a few problems, you'll be thorough with these radians as well. Then this is these are the angles. So now the interval over here at a regular interval of 30 degrees, all the values are taken from 0 to 2 pi. How do you substitute over here? It's up to you. You can use the degree value, that is sine. Say for example, sine. Theta is pi by 6 is 30, so I'll type this 30. Sorry, I have to clear the calculator. I'll tell you why in a minute. Sine 30, and now this is the answer, 1 by 2. So now, how do we consider this value is directly in the calculator? Over here, if you go and delete it and put pi, that is shift pi divided by 2, you won't get the correct answer. Now, the reason being, in default, your calculator will be in degrees mode. That means it can only take the input of degrees. It won't take a radian mode. Now, this is D over here. That is, if you press shift and mode, you will come to know Option number 3 is degree, but that is the default mode. Now this, if you want to use pi by 6 as directly, you need to change it to radian, that is by pressing 4. Now you can see the R value denotes a radian, and now I'm going to get the answer. See, okay, so it's pi by 2 I've taken, so this is the answer. Pi by 2 is 90 degrees. Let me type 90 degrees. But now if I press equal to, I'm going to get wrong answer. Why? Because it's in radian. Now 90, it's in terms of degrees, right? So I need to press shift, mode, and 3. Now I can see the D, that is degree. Now the answer is correct. Similarly, you can try any other value. You will get the same answer. So now say for example, I'll take 2 pi by 3. 2 pi by 3 is 120 degrees. So 120, now it's in degrees, that is root 3 by 2 or 0.9 is approximated. Let me take pi 2 by 3 pi. So it's 2 pi by 3, shift and pi. Now I cannot use degrees. I need to press shift 4 and radians, and the answer is root 3 by 2. That's 0.9. So this is how we can find the values of R. Okay, if you're getting confused with the radian, degree and all that, forget that. What you do is just use degrees. Simple as that. It's fine. So instead of taking the radians, just have degrees. 0, 30 degrees, 60, 90, 120, 150, 180, and so on. Okay, no need of taking these. So that's the thing. And now once you have the values, just sketch the graph. Now over here, once we sketch it, you will come to know. See, how do you sketch is 0 and 0. This is the polar grid. One point at 0 and 0. That's it. Now, next one. Now, all the points are over here. Yeah, most of the points are marked. Now, what about this? Pi by 6. Where is pi by 6? That is 30 degrees. What's the value? 0.5. So this is the point. Next, pi by 3 over here. 0.9. 1 is over here. 0.5 is over here. This is 0.75 and 0.9 is somewhere over here. Same way, pi by 2, that is 1, exactly over here. 2 pi by 3, and you just plot all these. Now, what about the other? See, you come over here, 0.5, this, and 0, okay? Pi is again 0. What is pi? What is the value of r? 0. We got the same point. Now, what about the next one? 7 pi by 6. 7 pi by 6 is in this line, right? But look at the value, it's minus 0.5. So you don't mark it in this, you mark it in the opposite side. It goes back to this. So again, you get the same points if you're starting to mark. So what you realize over here is these are repetitive. So if you're going to plot this, it's just the same over here, okay? This and this. So you do not need to do all these, but you just take few values and plot, you will get the circle. And then join the dots, and this is the graph. That's it. This is the answer. Similarly, you can check the answer for 3 cos theta. Same like whatever we just now did. Please try this by yourself. It is best you pause the video now, pause it right now, and do it by yourself. I hope you tried it by yourself by pausing the video. Now I will tell you the answer. It seemed like the last problem. We just now saw it. Take the intervals from 0 to 2 pi. It's just that theta, over here the r is 3 cos theta. Now we take the values from 0 to 2 pi at different intervals. You can take it in degrees like 0, 60, 90, and so on. And then put the values over here. You know cos 0 is 1, multiply by 3, it's 3. Same way, cos 30, and over here you will get the answers. Use the calculator for this, and then sketch it in the polar grid. When you're sketching over here, 0 is 3, so where is 0 and 3? This is the first point. Then pi by 6 is 2.6, so pi by 6, 2.6. And you will get all these points. So even over here, if you start graphing, when you do so much, then it'll be repetitive, sorry. See, over here you can see pi. Where is pi? In this line. But it's minus 3. That means you don't go at the front, you get the opposite side. 1, 2, 3. This is the minus 3 value. This graphing we had done in the last lesson. So if you do not remember the last lesson, please go back to the previous videos. then you will you will understand how to graph these in polar grid, because we have done many problems in the last lesson. Then in this, the only extra thing is making the table of values and then graphing it. So this is how we can easily solve it. Nothing much. It just depends on the equation, and then make some table of values, consider some values of theta and then graph it up. Now we will learn about the symmetry in polar graphs. Symmetry means being the same in both the sides, identical, like butterfly, half of the, not all butterflies, but many butterflies, left side and right side are symmetrical. If I have a line and I have a shape like this, then even the right side must be just like that, symmetrical. Okay, it should be exactly the same. Now this is a line of symmetry. Now the speciality in polar graph is, if the polar graph, the equation, the function is cos theta, then the symmetry is in polar axis. If any question is having cos in it, then the polar axis, the vertical line, right? This one, it'll be symmetrical. If I have, say, a shape like this, then over here it must be the exactly like this. Okay, now there's no graph like this, but I'm just giving you example. Up and down will be same. What is the importance in this? That means I do not need to find the graph, plot the graph for all from 0 to 2 pi. What do I do? From 0 to pi, that's it. That is 0 to 180 degrees enough, because whatever is the shape over here will be the same shape over here. I just don't know why this shape keeps coming, because I'm trying to do some other shape, say like this. Okay, now this and this will be the same. So why do you want to do 0 to 2 pi? Just do 0 to pi, that is 0 to 180 degree, and then just freehand the other side, or exactly the same points on the other side. So this will save you a lot of time. Now coming to the sine graph, sine function, it is symmetrical with respect to theta equals pi by 2. That means it's the vertical line. If you have, say, a shape like this, then left side will be the same thing. Okay, this is not equal, but in reality it'll be symmetrical. Okay, I hope you understand the concept. Now we will see some problems. Over here they have written, see, r equals 3 plus sine theta is symmetrical with respect to the line pi by 2. So whatever is over here will be over here. Now let's see some problems. We have over here, use symmetry to graph r equals 1 minus 2 cos theta. You know, cos is symmetrical to the polar axis. So make table of values, but the given equation is symmetrical to the polar axis. So just use from 0 to pi. Okay, make a table of value from 0 to pi, 0, 30, 60, or however you can take the interval, and put the theta value over here. You can take in degrees. Just now we have solved the same type. We are doing again the problems. And now it's 1 minus 2 cos theta. Apply these over here instead of theta, these values, and you'll get these answers. Now sketch the values. Over here, let us start sketching. 0. Now where is 0 angle? Over here. What is the value of r? Minus 1. So when it's 0, don't go to the right side one, it's minus 1. So this is the first point. Next, pi by 6. Pi by 6 is over here. Now it's minus 0.7. Instead of this, you go to the opposite direction, minus 0.7. Same way, pi by 4 over here, it's in the middle. Over here, go to the opposite direction, minus 4. Now pi by 3 is over here, but it's at 0. Then you have pi by 2 as 1, and you can plot the remaining points. You get like this. You will plot so much. So when you draw, see, look, you'll get like this line. Okay. Then the symmetrical line would be opposite. Now looking at this, you know the shape is Lamasan. Okay. Now over here, looking at the standard form, if you remember the classical curves, you can tell this is Lamasan. Okay, so that is one way you can easily tell it. Or looking at the shape of the graph also you can denote it. So this is how we can graph. I hope it's clear. Very simple table of values and graph it up. These are the classical curves. Now over here we have a real world problem. which says during a concert, a directional microphone was placed facing the audience from the center of stage to capture the crowd noise for a live recording. The area of the sound the microphone captures can be represented by R equals 3.5 plus 3.5. I'm sorry, this is point 5 sine theta. Suppose the front of the stage faces due north. Graph the polar pattern of the microphone and describe what polar pattern tells you about the microphone. Now, what it says is we need to graph this equation basically. Now, there is a concert going on and a microphone is placed somewhere over here. Now, the capacity of the microphone that can record the sound, if you keep a microphone over here, not all sound will be recorded. It has a certain capacity. Now, say this is its capacity. So, all the sound over here will be recorded by it, not something so far away. Okay. So now, when we graph this equation, we will come to know the capacity of the microphone. Let's do it. So same like the previous problem, make the table of values, but remember it is sine, so it is symmetrical with respect to the line pi by 2. That means just see it's pi by 2, right? So all that is over here will be symmetrical to the left side. So just mark, plot from this negative pi by 2 to pi by 2. Now, why we take negative pi by 2, or you can take it as 3 pi by 2 as well. It's 270 degree, or from here it is minus 90 degrees, right? To positive 90 degrees. So just plot points from there. The table of values, you're taking values from minus 90 degree to positive 90 degree. Take some interval, put these values over here. You can take it in degrees, put over here, solve, you'll get these answers, and then sketch the graph. When you graph, look over here, this is the shape. Now you do not need to do the entire till 2 pi, just 0, minus pi by 2 to pi by 2, and you got the shape like this. Now then you can extend, the shape will be symmetrical in the other side. That is how we get it. Now looking at the shape, you can tell it's a cardioid. Or looking at the equation, look over here, A and B values are same, isn't it? 3.5, 3.5. That means it's a cardioid. Now, what does it say? Like, look, we have to solve the second problem, right? Part B, information about the microphone. What does it say? The polar pattern indicates, look at this figure. This is a cardioid, okay? Which means if this is see, over here is the microphone. This is the microphone. Up until 7 units directly in front, vertical distance, until 7 units, it can record the sound. But at the right and the left side, it's only 3.5, 3.5. Say it's only 3.5 over here and 3.5. Whereas in the vertical, it is up to 7. That is what it says. So 7 units directly up front, it can record, and it can also record 3.5 units to the left side or to the right side. That is the capacity of this microphone. That is what it tells us about the microphone. Similarly, there's a check problem. I would kindly request you to pause the video, read the problem, and graph the equation by yourselves. I hope you paused it and try it by, when you try and solve problems by yourself, you get confidence to solve more problems. And during the exams, you will never be scared of any problem. You'll be more confident to solve. That's why try solving by yourselves, okay? Now let us see this how to solve it. Here the equation is given. Looking at the equation, I can say it's a cardioid, isn't it? A and B value are same. Now let us make a table of values. Over here also we have sine, so that means it is symmetrical to the line pi by 2. Make values from negative 90 degree to positive 90 degree. Find the value, put these in the in the theta and solve R values, and then you can just easily graph. This is it. Now graph one side and the other side is symmetrical. Again, we got a cardioid. That's it. This is the answer. So it is very straightforward. It's a real world problem, but mainly they have just asked you to graph over here. That's it. Okay, of the two lights. So this is the answer. It is very, very simple. Just remember, when it is sine, it is always symmetrical to the pi by 2. So the interval is from minus 90 to positive 90 degrees. Whereas when it is cos, it is from 0 to pi, the interval, because it's symmetrical to the polar axis. The second objective of the lesson was classical curves or special type of polar graphs. We had gone through in the first video of introduction. So if you have not gone through the first video of this lesson, that is the introduction video, please go back and go through the special type of polar graphs. So I'll just quickly recall. Now you will be given the equation, and then you need to recognize the standard form and then graph tell which type of graph it is. Say for example, circles, the standard form can be either a cos theta, a sine theta. If it is sine, it will be either up or down depending on the a value. If a is greater than 0, it's up, less than 0 is down. For cos, if a is greater than 0, it's right, less than 0 is left. Same way, Limousin's. So Limousin is basically okay. It's pronounced as Limousin or Limousin. So the C over here is as S. This is a C with a dash. So now over here there are four types of graphs, but one is also cardioid. Cardioid. We have done problems based on this. Whenever the A and B values are same, it can be it should be plus. A and B value must be same. So now it can be the cos or sine. It can be plus or minus. Now it depends on the equation. Based on the equation, you must know whether it is the inner loop Limousin or dimpled Limousin or convex Limousin. So it depends on the given equation. So you must be thorough with this equation and the type of graph. There are roses, it depends on the n value. We have gone through all this in the introductory video. And then there is, sorry, lemniscates. There are only two types. Either it is in this form, a cos or sine form. If it is cos, it is symmetrical along um, the axis, the center, sorry. Over here it's like this, left side and right side it's the same. But whereas over here, it is from the polar axis, it is symmetrical. And this is the spiral of Archimedes, the last one. Let us solve some problems over here. Now here we have been given a standard form, that is r square equals 16 sine 2 theta. We need to identify the curve. We need to tell the symmetry, zeros, maximum value, and r value, and also graph this. Looking at this, you will know if it's r square, only lemniscate has it. So see, this is a lemniscate because it's r square. Standard form is sine. Sine is this, so it's a square sine 2 theta. We just now saw it over here. See, this is the one. Now over here, it is symmetrical with respect to the pole. See over here, this is the pole. So it's symmetrical over here. And then this is lemniscate. And then what else can you know? This is the standard form. It's always like this, but this is not the graph for this one, because when we have values over here, when we make the table of values and graph, the graph will be different. Now what about the zeros? See, this is a sine function. Okay, so now the domain is restricted. See, look at this over here. If it was cos, then it would have been over here and over here. Okay, but this is sine. It's slanted. The domain is restricted to where and where? From 0 to pi by 2 and from pi to 3 pi by 2. This is very important whenever it is sine. Okay, so it's from 0 to pi by 2. This is the possible domain, and pi to 3 pi by 2. And where does it have zeros? It has 0 at x is 0 and pi by 2. So these are few things. And then what else do we have? The maximum value. Now maximum value, it depends. Now we will see over here, when we graph, we will get the answers generally. See, the maximum value, where is it happening? It is at pi by 4. Okay, so the maximum value, our maximum value, is at pi by 4. So when we graph, make the table of values, you'll come to know. And where are the zeros? At 0 and pi by 2. Okay, so now These are the this is just the basic understanding. The main thing is to make the table of values. So make the table of values from 0 to pi by 2. It's enough. Don't go to do both because it's symmetrical, isn't it? So just do from 0 to pi by 2. That's more than enough. Now you'll get the answer, you'll get the values. You can plot, see, plot these points, few of the points, and you'll get the answer. And then you can extend it over here as well. Okay, so this is how we can easily graph it, and that's it. This is the answer. But now the most important thing is understanding which is the standard form and which is the given graph. That is very important. Similarly, you can try this, but these are all different. Now it is better you try to solve all the different type of classical curves. Now in this video I'll just do a couple of problems. Now the first one was on lemniscate. Now we will do this, the standard form of spiral of Archimedes. Now here there are two conditions for spiral of Archimedes. Now looking at this equation, you can easily tell it's spiral of Archimedes. These are this is the standard form, r a theta plus b. Now the zeros and the maximum value. Now look over here. Does it have a maximum value? No. These just keep on going, isn't it? So there is no maximum value. You you can't bind this. It just keeps on going till infinity. So this has no maximum value. This is very important. But the zero is there at pi by 2. Now how we can do is substitute over here, make the table of values. You'll come to know. That's over here. We'll make the table of values. Now over here, since it is a spiral, we can't bind it. There is no domain restriction or anything. Look at this. It just keeps on going. So until how much will you do? Is it up till 2 pi? No, you can do until 4 pi. You'll get a better understanding. That is why we it's not symmetrical, so that's why we take some values of intervals from 0 to 4 pi. Even you can do 0 to 2 pi, but it's better you do more values. You'll get a better understanding. So you can take any interval and just make this graph. See, now initially you're taking more points over here, but as you go further, as you go more than 2 pi, just take 3 pi and 4 pi, because it'll be spaced like this. The spiral keeps on going like this. So now you have the table of values, plot the points and just graph it. That's it. This is the answer. So it's very simple and straightforward. If you're getting all confused with these directly, if you can't remember, okay, which is the standard form or anything, there is a simple way. Don't worry. What you can do is just make table of values and graph. Sorry, over here, make table of values and graph. Then you will get a figure, right? Then you will understand which type of classical curve it is. In this case, it is the spiral of Archimedes. And then you can say which is the zero, which is the maximum value. This does not have maximum value because it keeps on going. So you can find the basic details of it. So this is how we can do it. For any equation, just graph it directly, and then you can find the shape, and then you can tell about the graph. So this is it. So that is the end of this lesson. I hope you understood this lesson. If you have any doubts, please go back to the previous videos, watch the videos in continuity. But if you have any doubts, please write it in the comment section. I will try to get back to you as soon as possible.